All right, we're going to keep going with our quadratics today and looking at parabolas. We're going to look at how you can use a factored form today to find some other information. So we've looked at standard form, which is this one, where you got ABC in there. You can use those to do some different things. We have vertex form, which is very convenient if you want to know where the vertex is or have the vertex and want to be able to work with it. Today we're going to look at the factored form of the vertex form. Where both of these x1 and x2 would be your x-intercepts of the graph. So if you know about the x-intercepts and you put in this factored form, then you can still find the equation of the parabola if you can figure out what that a is. And that a is the same a that you see in these other equations telling us like how which way it's going to open and how wide or narrow this parabola is going to be. Okay, so this first example here, it says a parabola has x-intercepts of -10 and 2, and it goes through the point 4,7. Find the equation in standard form. Okay, so that tells us something. If we know the x-intercepts here are at x equals -10 and x equals 2, that can give us a way to write this equation out. So what we know is in factored form, our equation then is going to be y equals a, x minus x1 and x minus x2. So in this problem, our x1 is going to be this one, our x2 is going to be this number. So now we want to plug those in and see what we get. So we're going to end up with y equals a times x minus -10 here and x minus 2, because those are the two numbers we got in. So it's going to end up being that we got a minus a negative, the same as +10 and x minus 2. All right, so what we're stuck with those, we got to figure out what that a is. So how we're going to find that a is to use the last piece of information up here. And the last piece of information is we know this 0.47. So what we're going to do next now is plug in the 0.47 into this equation, meaning if we have that 0.47, that tells us when x is 4, y is 7. That's an ordered pair there. So we're going to plug into this equation here 7 in for y, and then any x's we're going to plug in 4. So we're going to put a 4 in for that x, and we're going to put a 4 in for that x. Now, because there's only one variable here of a, we should be able to solve that out and figure out our one missing piece of information there of a. So just doing a little math now, 4 plus 10 is going to be 14. 4 minus 2 is 2. Multiplying that together, that's 28. And dividing, we can now figure out what a is. A would be 7 over 28, or that's the same as a equals 1/4 if you simplify that. 7 goes into 28 4 times. So a would be 1/4. So now what you're going to do is write that out and see what that looks like. So we're going to plug that back in now for a and see what our equation is. So we're going to take this, the fact that we know a equals 1/4, substitute it back in here now, and we can get that equation. And our goal, I believe, is what they said is write the equation in standard form. So now we got 1/4 times x plus 10, x minus 2. We're going to go through and FOIL that out first, distribute, multiply first, outside, inside, last, and see what we get. So if we do that, x times x is x squared, minus 2x if you multiply the outside ones, plus 10x if you multiply the inside ones, and then 10 times -2 is -20. We have some like terms we can put together in there. So I'm going to do that first. -2 plus 10 is 8x minus 20. And then finally, we got that 1/4. So that 1/4 we want to distribute through here, and we get 1/4 x squared. 1/4 times 8 It's kind of like 8 over 4 or 2x, and then 1/4 of 20 would be 5, so minus 5. So that would be our equation in standard form. Okay, the last part of this, it looks like they wanted us to do some graphing here. So the graphing part of it, we know some stuff here. They did tell us that the x-intercepts here were at 2 and -10, so we could put that on here. We know we have a point there and a point here, so those are 2 points. It'd probably be good if we had the vertex. We can now come up with a vertex if we know the standard form down here. Remember, our vertex is going to be using that x equals -b over 2a. So here our b is 2, and our a is 1/4. So we want to solve that out. That's -2. 2 times a fourth is a half. To solve that, we'd multiply by 2 here to both top and bottom, because 2 is the reciprocal of 1/2. And so it looks like -4. So we know our line of symmetry here is at -4. And our vertex is somewhere on that line. Now we just got to plug that back in to find out the y value of our vertex. So if we put -4 in here, what do we get? Make sure you square before you multiply here. We don't want to take 1/4 of 4 and get -1. We got to square first. So -4 times -4, is 16. Jumping ahead of myself there. 2 times -4 is going to be -8. 1/4 of 16 is 4. So now if we go through and do that math, looks like we get -9. So we know that the vertex here now is at -4, -9, and our parabola looks something like that. Okay, let's try another one. This one, a parabola has a vertex at -2, 2, and a y-intercept at 4. Find the equation in standard form and a graph. All right, so first off, if we were doing the graphing part of it, we got a lot of information that we could get a pretty decent graph here. -2, 2 is the point right there. That's the vertex. So that would also tell us the line of symmetry is at x equals -2. We got a y-intercept at 4. Okay, so that's telling us if we got a y-intercept here at 4, that there's a point in the graph then that goes through the point 0, 4, being right there where we graphed it. And we know there's always symmetrical points, so if this is 2 spaces away from our line of symmetry, there should be a point there as well. So we got a pretty decent idea here what our parabola looks like as far as graphing it. But they did want us to come up with the equation in standard form. So what we're going to do here now is write out what we know. If we have the vertex, we should be able to start with that vertex form and use that vertex form looking like this again, a times x minus h squared plus k. So here, if we put in our information about the vertex, we get that y equals, we don't know our a, but we do know our x value is -2, and our y value of the vertex is 2. So that gives us now the equation a times x plus 2 squared plus 2. All right, but we still need to figure out what a is. So like we did in the last problem, we're going to plug in the other point we know. And the other point we know is that y-intercept right here. So we're going to plug in that y-intercept of 0, 4, meaning when x is 0, y is 4. So if we plug that in, put 4 in for y, put 0 in for x, and solve this out, we should be able to get to the value of a here. Now to solve that, looks like we're going to need to subtract 2 here to get rid of that. So that means we're going to have 2 over here now. 0 plus 2 is 2, and 2 squared is going to be 4. And so now if we divide both sides by 4, because we're multiplying here, looks like our a value comes out to be 2 over 4, 1/2. So now just plug that value back in, like we did on the last problem, in for a, and then we got the vertex, or the equation in vertex form, which would end up being y equals 1/2 times x plus 2 squared plus 2. So that's the vertex form of the equation. But again, they did want standard form. So what we have to do is go through and simplify this down and get it into standard form. To do that, we can't distribute this 1/2 because there's an exponent there. So we got to deal with that first. And remember, if you got an exponent of squared, that means you're multiplying two of these x plus 2's together. So first thing we're going to want to do here, we're going to want to again FOIL or distribute and multiply that through. So what do we get if we were to do that? So you get x times x is x squared. If you multiply the outside ones, you get 2x. If you multiply the inside ones, you get 2x. Together, that's 4x. And then 2 times 2 is 4, multiplying the last ones. Next, we can't add 2 yet. We got to multiply before we add here. So we want to distribute that half all the way through here. So now you got 1/2 x squared. Half of 4 is 2. So we got that plus that additional 2. And so our standard form equation here is 1/2 x squared plus 2x. 2 plus 2 is 4. That would be the standard form equation of this parabola. And we've graphed it already. Okay, next one. Parabola has a line of symmetry at 1, and one of the two x-intercepts is 3. The parabola goes through the point 2, -6. Find the equation in standard form. Let's start with graphing on this one. So if the line of symmetry is at 1, let's put that on there. That was the first thing they told us. So we got that. One of the two x-intercepts is 3. So that means over on the graph here, we got a point right there at 3. But in reality, that also tells us the second x-intercept. If we know we have one x-intercept here at 3, we should also be able to find the second one because we know the line of symmetries here. This point's 2 spaces away from this. That means the second x-intercept has to be 2 spaces away from as well. So it looks like our second x-intercept then is at -1. And then finally they tell us there is a point here on this graph at 2, 6, or 2, -6. So let's put that point on there. So there's a point right here at 2, -6. Okay, so this is similar to that first problem we did. We want to use the factored form of this. So the factored form then, again, looks like this. If you did it in factored form, it's going to be y equals a times x minus x1, x minus x2. So in this problem, if we do that same thing, it's going to be a times x minus 3, and then it'd be x minus -1, which is minus and negative is the same as plus, so x plus 1. Okay, so that's our equation, but again, we got to find a. So let's use our point again. This point right here of 2, -6, where x is going to be 2, y is going to be -6, and put those numbers in. So doing that now, you got -6. Both x's we're going to plug in 2, and then solve this out for a. So here now we got -1 times 3, which is going to be -3. And divide, if we divide two negatives, it should come out positive. Here our a value is 2. So now, to finish this one off, let's plug that back in and solve this out. So if we plug 2 back in, now we got 2 times x minus 3, x plus 1. Let's go through and multiply and FOIL that out, and then we'll distribute our 2. So x times x is x squared. We got a negative 3x and a positive 1x. That's going to add to negative 2x. And negative 3 times 1 is negative 3. Distribute our 2, and we got our equation here in standard form. Okay, now the last thing, we do need to finish graphing here. We got 2 points here. We know there'd be another symmetrical point right here. I think the only point we're missing there would be that vertex. And we know the vertex is at 1, so if we just plug 1 into this equation, we can find that. So plugging in 1, that's going to be 1 squared is 1 times 2. So it looks like our y value comes out here to be negative 8. So we know our vertex is at 1, negative 8. Now we can finish graphing that. All right, your turn. This one, they tell us parabola has these two x-intercepts, and it goes through the point negative 3, 14. Why don't you pause the video and see if you can come up with the equation first, and then we'll join back together and then see if you can do the graphing part. All right, let's see what you got. If you started off with our factored form here again, you started with that. We know these are the two x-intercepts, so if you put those numbers in, we're going to end up with x minus 4 and x minus a negative 2, or x plus 2. Now plug in that point you know of negative 3 for x and 14 for y. Solve. You should have got that a is 2. Then plug that back in, and you should end up with this standard form equation here. All right, next part, they want us to graph this. So see if you can, again, pause and then graph this out and check it. All right, let's see what you got here. I chose to, I graphed these two y-intercepts out, or x-intercepts out. Here, just sticking with 1 as our way we're labeling these. With the y-axis, though, because we got some bigger numbers, I chose to skip by 2 here so we could fit these points on the graph. So we know we have a point at negative 3, 14 here, which would be right there. Also then, what we're going to have to try to figure out is what is that vertex here. So we can use our little vertex equation again here of x equals opposite of b over 2a. Putting in what we know here. That's going to give us positive 4 over 4, or 1. So on our graph here at 1 is our line of symmetry. Meaning we could get some other points right away here. We got this point at negative 3, 14, which is 1, 2, 3, 4 spaces away. So there should be a symmetrical point 4 spaces away here. But we still want that vertex. It's somewhere on that line of symmetry. Plug that back in now, and you can figure out the y value of this. So if you plug in 1 for both those x's and solve, we're going to come up with negative 18 there. So 1, negative 18 is our vertex. Now we got the graph of this one. So it should look something like that. All right, one last one. This one tells you the vertex and the y-intercept. See if you can get the equation in standard form. So again, pause, try this one out, see what you get. Okay, let's see how you did. We want to start with the vertex form on this one, which is this. Plug in the point we know of 2, 4 here. So we're plugging 2 and 4 in for the two vertex values. Now you got to plug in the y-intercept point of 0, 16 in there. Putting 0 here, 16 here, and then solve that out. We can minus 4. Square negative 2, you get 4. Divided, you should have got 3. Now plug that value of 3 back in for a here and solve it out. Remember, if you got something squared, that means you want to multiply 2 of these and FOIL that out. Then distribute our 3 here, and then finally add that plus 4 in, and this was the standard form equation you should have gotten. To graph that, if the vertex is at 2, 4, that means we know the line of symmetry is at x equals 2 here. We also know that vertex is at the point 2, 4. So right here, we got a point at 0, 16. That's a little bit off our graph. So again, you could change, if you wanted to change what we're labeling this by to graph it, you could do that. So maybe let's go by 2's here. That does mean we're going to have to change our 1 point that we did have on there. So now our point here should be, if we had 2, 4 is going to be 2, 4's right here. We got that y-intercept at 16. There should be a symmetrical point there. And our graph would look something like that. Okay, so that's what you're going to be now doing and trying out on your own with the practice sheet.